with a different topic, which is t-test, and it is a very unique concept of biostatistics, and this would be mostly required by CSIR NET aspirants or in general any biology enthusiast. So let us quickly start with the topic. So what is a t-test? A t-test is a statistical test. A t-test is a statistical test that is used to compare the means of two groups. Compare the means of two groups. So what do we mean by that? See, in the blackboard here, I have written two groups, and this is, for example, bone density of two groups, group 1 and group 2. So this is the sample data. So what is the population here? Here I have taken, for example, 5 members in each group. So there would be some mean of this group 1 value. What would be the mean? 1 plus 1.5 plus 2 plus minus 1 plus 0.5 divided by 5. Okay, so this would be the mean of one group, and similarly we will get another mean of the second group. Now we have to understand that are these two means really different, or they are similar, or they might be different, but are they significantly different, like to assign them like two different groups? So we have to learn all these things, and for this we need t-test. So t-test is a type of inferential statistics. Wait, let me change the ink color. Inferential statistic which is used to determine if there is a significant difference between the means of two groups which may be related in certain features. Okay. Now, so after doing this t-test, I will later come to the formula and everything. We will get a value known as t-value. We will get a value known as t-value. Now, if this t-value is large, then what that I will tell, then there is a corresponding value based on the degrees of freedom and the significance level. I will come to these things later on. So for now you can understand, if the t-value is large, the two groups belong to actually different groups. Okay, so if the t-value is large, the two groups are basically different groups. And if the t-value is small, the two groups belong to the same group. Now, few of the terminologies. What is one terminology? That is degrees of freedom. It tells us the number of independent variables used for calculating the estimate between two sample groups. So what is the formula of degrees of freedom? It is sigma ns minus 1. For example, for this one, it would be, wait. Here, there are 5 plus 5 samples in group 1 and group 2, minus 1. So 9 will be the degree of freedom. Clear till now? So this is one of the terminology that is involved in t-test, that is degrees of freedom. Now we will be coming to another point, that is significance level. Significance level. Now this understand very carefully. It is the probability of rejecting the null hypothesis when it is true. It is the probability of rejecting the null hypothesis even when it is true. In simpler terms, it tells us about the percentage of risk involved in saying that a difference exists between two groups when in reality it does not. Okay, let us understand it easily. For example, here there is group 1 and group 2. Now we are telling that okay, group 1 is not equal to group 2 or group 1 is equal to group 2, whatever conclusion may we come to. So what is significance level? Significance level is the amount of risk we are taking, in giving a perfect conclusion to this sum. Like, what is the probability that my conclusion will be wrong? So what is the risk I am taking in coming to this conclusion? Okay, is it understandable? For example, I tell group 1 is equal to group 2. So what are the chances that my conclusion is correct or not is the significance level of my result. So this is one term. Now there are different types of t-tests. Independent t-test, which compares the means for two groups. Like I told you, there is a group 1 and group 2 where there are certain values of bone density. There are certain values of bone density. So here we are comparing between two groups. So this is independent sample t-test. Now there is a paired sample t-test. Here what happens? Compares means from the same groups at different times. From the same groups at different times. What is that? Let us take this same bone density example and let us see. For example, group 1 has bone density of 0.1, minus 2, 0.25 like this. Now we are giving them vitamin D supplement. Now we are giving them vitamin D supplement. Now what happens to this same group 1? We can think that it has increased. More than 1 is good as a bone density unit. Okay. 5 will remain 5. So this is a comparison between the same group. Okay, so this is a comparison between the same group before and after some experiment. So this is known as paired sample t-test. So this is known as paired sample t-test. Now there is one sample t-test where the mean of a single group against a known mean. Like the known mean or the mean that should actually occur is ready with us, is calculated. So we are judging our experimental group based on that known mean. So this is another type of t-test which is known as one sample t-test. Now let us come to independent sample t-test. That is the first one. Okay. This can be single or paired. Now what happens here? Independent sample t-test, commonly known as unpaired t-test, is used to find out if the differences found between two groups is actually significant or just a random occurrence. So here the population mean or standard deviation is unknown. Obviously, known is where in this one sample t-test. Here it is unknown. And the two samples are separate and independent. Not like this, that after experiment something will be the result. It should be two different population altogether. Like our previous example of bone density. Okay, so now let us come. Few assumptions are there in t-test. As we know, in statistics there are certain assumptions. So here also there are certain assumptions that the data are independent, that is, they are not dependent on each other. Like for example, if one person has a bone density of if one person has a bone density of 0.5, it won't affect the bone density of another person having one value. Okay, so that is they are independent and they should be normally distributed, like at least partially normally distributed based on this bell curve. And another is that they have a similar amount of variance within each group. Within each group there should be a similar type of a variance. If we have to consider that group eligible for a t-test. Okay, we shouldn't think the other way around. If the variance is not like similar, then how the t-test will give proper result? Okay, if the variance is not similar, we will not participate that group into t-test. But if we have to perform t-test, we have to keep certain things in mind. Okay, so if we have to find out what is the difference in the mean bone density between two separate population, we have to perform a two sample t-test. Now what is the formula? X bar 1 minus x2 bar divided by sp into a square root of 1 by n1 plus 1 by n2. So what is this? X bar 1 and x2 bar, these are means of sample 1 and sample 2, rather group 1 and so these are mean of group 1 and group 2. Let me another time write the data for okay, so group 1 and group 2. Something like this is the data for our t-test. Okay, so what is x bar 1 and x bar 2? It is the mean value of group 1 and this is equal to sigma of all the samples divided by 5. So this is mean of group 1, this is mean of group 2. Now what is this SP? What is this SP? SP is the pooled standard error. SP is the pooled standard error, which I am going to explain later on. N1 is number of samples in group 1. N2 is number of samples in group 2. So we are getting all the values of this formula except SP. Now what is SP? SP is N1 minus 1, that is 5 minus 1 into S1 square. What is S1 square? Total standard deviation of this group. Total standard deviation of this group ka square. That means whatever mean it will be, x1 bar is the mean. Okay, so x1 bar minus 0.1, x1 bar minus 0.2, like this. x1 bar minus of -1. All these values will be taken together, will be added, and wait, let me x1 bar minus 0.1. x1 bar is the mean, okay? All this will be summed up. All this will be summed up and iska square. And we will take square of this. Everything will be summed up and then that value will be squared. So this will be S1 square. Similarly, S2 square. Divided by what? Divided by degrees of freedom. That I told you. What would be the degree of freedom? Here, what is the sample size? 5 plus 5. So it will be 5 plus 5 minus 1, 9. Okay, so we are getting SP in such a manner. SP in such a manner. That we will put here. This is T equal to this thing. SP will be calculated like this. Now we are having our T. Now we are having our T for group 1 and group 2. Now what will happen? So now what we will study? That if the p-value that corresponds to the test statistic T with this much of degree of freedom is less than the chosen significance level, then you can reject the null hypothesis. Now let us draw a table. Before going into further explanation, let me draw a table. So this side it will be degrees of freedom. This side it will be significance level. What are the common significance levels? 0.10, 0.05 and 0.01. So these are the few significance levels. So we are going to choose here significance level 0.05. We are going to choose here the significance level 0.05, which means there is a 5% risk that to whatever conclusion we are coming to might be the reverse one. Okay, might be the wrong one. There is a 5% risk. So there are several other values here. 0.1, 2, 0.5, 1.25. Maybe 0.05, etc. There can be several values like this. Okay. Now we have different degrees of freedom. Let's say these are our degrees of freedom. Okay. Now what is our degree of freedom? It is 9. And we are choosing the significance level to be 0.05. We are neither making it too lenient that okay, our result might be at a risk of 10%. Neither we are choosing this 1%. We are keeping it towards 5% risk, that is 0.05 significance level. So what is the corresponding value? It is 1.25. Now let us assume our, 1.25 T value is, for example, 1.25. Our T value is 1.25. So what this is? This is same. Let us think as 1.20. So this is less than 1.25. This is less than 1.25. Now what it is written? If it is less than the chosen significance level, then you can reject the null hypothesis. Then you can reject the null hypothesis. Now, what is null hypothesis? In general case, in case of two sample t-test, the null hypothesis, like before doing the experiment, we have to hypothesize a situation, correct? That is mu1 equal to mu2. That is, these two groups are equal. Now what we are doing? We are rejecting the null hypothesis. That means we will tell, okay, these two groups are not equal. So the alternative hypothesis might be correct. Okay, that is, these two groups are not equal. Within this alternative hypothesis, there are few other divisions, like two-tailed means just mu1 is not equal to mu2. What is left-tailed? Here it means population 1 is less than population 2 mean. Mean of population 1 is less than that of population 2. And mu1 greater than mu2 means population 1 mean is greater than population 2 mean. So these are the three divisions of alternative hypothesis. So what do we understand from t-test? We can understand that the mean of two population is same or different, which gives us an idea that the two groups that we are thinking as two groups are actually two groups or can be placed within a single group. So this is a overview of t-test. Hope you like the video, and this will be going into concept clearing videos of CSIR NET, but in general any biology enthusiast can study this. So let me know how much do you like the video and what kind of topics would you like more. So thank you, happy learning, till then, bye bye.